Hi everyone, welcome to the Osmosis Required Practical. Now if you want a deep dive into osmosis, go to the live webinars because I did one last Monday. This is just the required practical. So picture potatoes there because it's normally carried out with potatoes, but it can be carried out with any old vegetable. I've seen beetroot, carrots, parsnips, turnips, all sorts, but it's the same experiment. Okay, so first off, our definition for osmosis, we need to know this, and we need to know it word for word, is the movement of water from a high to low concentration through a partially permeable membrane. So whenever you're thinking about osmosis, you are thinking about the concentration of water, so high to low concentration of water, okay, not salts or sugar or anything else. Now then we need to know what a partially permeable membrane is. So that is a membrane which has tiny holes in it, and some substances are let through and some substances are not. So it has several different names. Partially permeable is one. Different teachers do different ones. So you could also have selectively permeable, which is perfectly acceptable, or semi-permeable. Either of those are absolutely fine, but it just means the large molecules like salt and sugar can't move through it, but the water can, because water is quite a small molecule. And what is the partially permeable membrane in the cell? Cell membrane. So things are going to be moving through the cell membrane, okay? And it's going to be the water moving through, and it's either going to be going in or going out, depending on the concentrations of water. Right, so make sure you know all of those. So just as a little demonstration here, we've got high concentration of water over here. These blue molecules are water. And we've got low concentration of water over here. Even though we've got a high concentration of solute, we're not even going to think about that. We're just going to think about it in terms of water. So this is the higher concentration of water. So the water will move this way. It's trying to dilute the solute, basically. It's trying to even it up. Okay, so with that in mind, this is our required practical. Now this is one version. You may, like I said before, get a different vegetable, and you may, get, let's go this side, salt solution, or you might get sugar. It might say sucrose, it's a type of sugar. It might say glucose, but it all works exactly the same way. Okay, so don't worry if it says sugar and you're used to looking at salt, it's fine. So this is one method. They're all slightly different, but the ultimate aim is the same. If you want to pause the video now and have a little read in your own time, that's fine. So pause now if you want to do that. Okay, so basically what we're doing in our steps is we are cutting potato cylinders. So when I say cylinders, you probably, where's my pen gone? No, it is. You probably used a cork borer, and we're cutting this kind of effect from the potatoes, and they've suggested lengths of 3 centimetres. Now you're never going to get them the perfect 3 centimetres, all of them, but you want as close to it as you can with a ruler. Cut the ends off the potato because they're impermeable. Nothing can move through the ends where there's skin. Record the length using a ruler and the mass using a balance. Okay, so we're taking the mass of these potato cylinders, and then we're going to pop them into different sugar solutions in this one. So we've got here, right up this end, distilled water. Now sometimes they'll have the distilled water at this end, Sometimes they have it at the other end. So if you get this kind of question, make sure you check. And this 1 molar solution is our, shouldn't say strongest, correct, most concentrated sugar. Okay, so this end's distilled water and this end is the most concentrated sugar solution. Once we put them in, we're going to leave them for a certain amount of time. 24 hours is ideal, but sometimes it's just an hour or something if you're doing this in one lesson. We're going to take them out and then we're going to dry them. We'll look at why we dry them in a minute. We're going to then record the lengths and masses. Now bear in mind it's usually masses that the questions are about. And calculate the percentage change in length and mass. So this little table here, it's got 3 sucrose concentrations on it. It's got the mass at the start, the mass at the end, and then the difference in mass. So this is going to be 0.6 because we're taking the smaller one away from the big one. This one's going to be nothing, it doesn't change. And this one is going to be 0.5, but it goes down, so we're going to say minus 0.5. Now we can use those masses, but a better way of expressing it is percentage change. Okay, we'll look at why that's better in a minute. So you might get change in mass, you might get percentage change in mass. You could get either, depending on your exam board, depending on whether it's combined, whether it's triple, depends on foundation or higher and where it is in the paper. Okay, so just be aware of both. Right, so that's the method. So what I want you to do is jot down that method on a revision card. Just the key words that you need. Cut potatoes in tubes. Take the mass with the balance. Pop into our solutions. Remove and dry. Reweigh. Okay, so nice simple steps. Because if you have to write this method, it's 6 marks. All right, so let's have a look at our next one. So we're going to answer some of these questions and pick up some of the questions that are asked in exams. Right, the dependent variable, so this is the one we're going to measure, is our mass. Okay, now I'm quite happy for you to pause the video and have a go at these first, but I'll go through them now. So independent variable, so this is the one that you are in charge of. I've lost my pen, where's it gone? Ah, there it is. The one that you are in charge of. Hopefully you're all shouting out sugar solution concentration. It could be salt depending on the experiment. Oh, 2 control variables. So things we need to keep the same to keep this a consistent test. We should have temperature, should be the same. Volume of solution. Time left in there. Okay, there's probably more, but that's 3 perfectly acceptable ones. Explain why the ends of the potatoes are cut off. Oh, I had an accent then. They are impermeable. If you can't remember that word, then please just say they won't let water through them. That's absolutely fine. Name the piece of equipment used to measure the length of the potato chip. This is not a trick question. All they want is ruler. Okay. A top pan balance is used to measure the mass in grams. Suggest why the resolution of the balance needs to be high. Now, if you're not sure what resolution is, it's basically how many decimal places there are on the balance. The higher the resolution, the more decimal places there will be. So if you have a balance that measures in whole grams, so you'd have 1 gram, 2 grams, 3 grams. That is a lower resolution, one that measures to 1 decimal place. and so on. Okay. Suggest why the resolution of the balance needs to be high. Because we have very small changes in mass. You would not be able to measure those changes in mass on your bathroom scales that you stand on to see what your mass is, because the resolution is not high enough. Okay. Suggest why a bung is placed on the boiling tube. This comes up a lot, but for some reason teachers don't mention it very often. It's probably because they don't have enough bungs in the department to bung all of the tubes when you do this experiment. But if this comes up, to stop evaporation, because if any of that water evaporates, it's going to change that solution. Why should it be dried? Well, I'm hoping you're going to say remove excess water, because that excess water actually weighs something. So it would not be great for our results. Explain why you dab or roll the potato chip instead of leaving it to stand on the tissue. That's so we remove water from every surface. This experiment, by the way, I don't think I've seen an exam paper without it in. I think it comes, I've seen it every year, so know it well. Calculate the difference in mass for each potato in the results table. We've already done that. And then the next bit is state the percentage of sugar solution where the chip gained most mass. Right, so we're going to go back here. And the one that gained most mass was our 0 concentration. So this one down here is the one I'll put up for increase in mass, which is the biggest increase in mass. And this one here, sorry, that's increase. And this one would be the biggest decrease in mass. Now, why does this increase in mass, I hear you say? Please explain it to me. So, biology words for explain. Water moves in. Biology word, by osmosis. From high to low concentration. I believe the next question is explaining this one. So we're going to say the opposite. Water out by osmosis, high to low concentration. Now, if you get explain in an osmosis question, these are your key words. It's either going to be water in or out, water out, by osmosis, and then high to low or low to high to low, depending on which one they ask you about. But those are your key words that you need to be talking about, and I'll show you an example in a minute on a question. Okay, so we've done 10, 11 and 12, 13 and 14. So use the equation given to calculate the percentage change in mass of the chip in each solution. Now, percentage change, there's an equation, and it's really important that you know this equation, because actually it comes up in maths, it comes up in physics, it comes up in chemistry, and it comes up in biology. That's potentially a lot of marks over your exams. So it says here the final mass minus the starting mass over the starting mass times 100, because it's a percent. Now there's an easier way to remember it. Change over the original times 100. So the change here would be 0.6 divided by the original 2.6 times 100, and that should give us I believe it's 11.1, but don't quote me on that. No, that's one of the other questions. You can work it out and let me know in the comments. Okay, right, this is a standard one. Why do we use percentage change in mass instead of just the change in mass? So if it's 1 mark, we are going to say it takes account of the starting masses. Okay, because they're not all the same starting mass. If it's 2 marks, we're going to add compare the results. So it's very hard to compare results if you haven't got the same starting mass. Okay, 17, we might be asked to compare our results with others. Suggest the advantage of comparing results with the results of others. So it's a suggest, so anything sensible. Hopefully we'll get a mark here. So something like check the results are correct. Check for anomalies. Those are our 2 standard ones. Right, last little bit here. What is the potato representing in this experiment? And what could be used instead of a potato? So I've named some already. And what's the potato representing? It's the cell. So it's got lots of cells. Suggest how you could improve. I would suggest to you, if you can't think of anything, always put repeat and calculate a mean. Okay, don't just put repeat because that won't get you a mark, but repeat and calculate a mean will. So I think I've gone through every possible scenario question for the osmosis practical there. Now the graph. So this is just like a standard graph here. We've got the gain in mass here, or the percentage gain in mass. And then we've got the loss here. Now, this one hasn't got the axis on, so I think they were 0.25, 0.5, 0.75. Well, I think that's the ones they used. So we said the 0 molar, the pure water, is going to go up the most. So that's going to be here. The 1 molar is going to go down the most. That's going to be something here. And then the others will hit somewhere in between. Now, quite often, this is a curve. Okay, not always. Judge on the points when you've plotted them, but sometimes it's a little curve. Now, the other thing they will ask you is, what is the significance of where it crosses the axis? Okay, this bit here. In this case, it's about, I would say, 0.375 molar. That's where it crosses. So at that point there's no increase in mass, and then there's no decrease in mass. So that tells us the concentration inside the potato cell, because there's no increase in mass, there's no decrease in mass. So there's no water movement. That's because it's the same inside as outside. So it might ask you to read that off. Now, it will be judged on your line of best fit. So your line of best fit is where you think it is. Obviously, it can't go the opposite way or something. And then you are judged on where your line of best fit crosses that line. Okay? So don't panic if it's not exactly the same as everyone else's, because it's your line of best fit. Okay, so that's what the graph should look like. And now we've got a question. Now, what I suggest you do is just pause the video, have a little read, do that now. So this is very, very similar to the other question. We've got sugar solutions and it's potato. Sorry, it almost cut off at the top there. And we've got 0.8 molar, 0.6, 0.4, 0.2 and a 0 molar. 5 potato cylinders. We're going to weigh them, leave them for 24 hours, reweigh them, reweigh the potato cylinders. So dry them, then reweigh them. So standard method. Let's have a look at the question. So here is our very lovely table of results. So we've got our starting mass here, our final mass, our change in mass, and very nicely they've calculated most of the percentage change in mass. Calculate the value of X in the table above. So remember, change over original times 100. Now this is the bit that I believe is 11.1%, but you can put it in your calculator and have a go. Oh look at this question. Why did the student calculate the percentage change in mass as well as the change in grams? Take account, if you remembered this from the page before, of starting masses, and if you needed the other one, compare results. Now if I gave you 10 questions on osmosis, they would all have very similar marking points, and the explain bit would always be the same marking points. Okay, so it's those key words you're trying to get. Let's have a look at the explain bit here. We're going to jump the graph because we've just done that. The results in the table above show the percentage change in mass of the potato cylinders. Explain why the percentage change results are positive and negative. So why are some positive and why are some negative? Right, so the positive ones, where it goes up, so where the mass increases, remember our keywords. Water moves in by osmosis. Now you can, if you want to, it's often a mark as well, through the semi-permeable membrane. Okay, and when they go down, obviously you're going to write it in slightly better sentences. Water out by osmosis, and both of them are high to low concentration. This is because it's explain. So this is where biology words come in. Okay, hopefully you're all okay with that one. Now, this bit here is just for higher, combined and triple, but higher, because sometimes they throw this in, okay? They will throw in the eggs with osmosis. So if you think about an egg, underneath the eggshell is actually a lovely perfect cell membrane. Okay, so some experiments, they will get you to, now you won't have to write this method, but you might have to read it and interpret it. Remove the shell of the egg and then use the whole egg instead of the potato tube. And water can move in and move out of that, just like it can a cell. Because actually, if you ever hard-boiled an egg, you take the shell off, there's a lovely cell membrane around the outside. So just be aware of this one. If you see something about eggs and removing shells and you're going, what on earth is this about? It's probably about osmosis. So let me just show you an example. We're not going to do the whole question, but I just want to show you an example here. So, a student carried out an investigation using chicken eggs. So what they did, they put 5 eggs in acid for 24 hours to dissolve the eggshell. Then they're recording the mass. Then they're putting it in distilled water. Then they're taking them out, drying them with a paper towel and recording the mass. So what you get here for this one is the mass, because they're all going in distilled water here. The mass is going up, it's increasing. Okay, so this one they just put it in water, but it works exactly the same as your potato. So don't be phased if they're removing shells and then either putting them in distilled water or putting them in salt or sugar solutions. It's likely to be osmosis. Okay, we are going to stop there. I hope that's helped with this required practical. And on to the next one. Well done, everybody.